Welcome to The Explainer. Today, we're diving deep into an absolutely epic story, a story about the very foundation of our modern connected world. I'm talking about the telecommunications industry. And look, this isn't just a tale about getting faster download speeds or the rollout of the next G. No, this is a much bigger story. It's a story of a truly global industry that found itself in a massive crisis, staring right over the edge of a cliff. And what we're going to explore is its monumental, high-stakes struggle to reinvent itself literally from the ground up. We're going to trace the entire arc of this upheaval, from a business model that was fundamentally completely broken to a future that's being built right now on these radical new ideas of open, automated, cloud-native intelligence. It is a story about technology, for sure, but underneath it all, it's really a story about survival.
To really get our heads around this massive industry-wide shift, we've structured our journey like a 6-act play. First, we'll start at the precipice. We need to feel the full weight of the crisis to understand why this radical change wasn't just a good idea, but an absolute necessity. Then we'll get into the Great Unbundling, which was the first truly revolutionary attempt to fix the problem. In Act 3, we'll see how the industry had to lay the cloud-native foundation, a new layer of automation needed to manage all the new complexity. Act 4 is where it gets really futuristic, the AI infusion, where we start layering real intelligence onto this new platform. Act 5 is almost a little thriller all on its own, the quantum threat, a looming danger to everything we've just built. And finally, we'll wrap it all up with Rebuilding Babel, where we look beyond the tech to the final, and frankly, the hardest frontier of all, the human and cultural changes needed to make this all work.
All right, let's jump right into Act 1, the precipice. To really appreciate the incredible solutions we're going to talk about later on, you first have to understand, you have to feel the sheer weight of the problem. You see, this whole transformation, it wasn't a choice. It wasn't a bunch of execs sitting around a table saying, hey, let's innovate for the fun of it. Not at all. This was a desperate, back-against-the-wall, existential fight for survival. And it was born from a deep, structural, and frankly seemingly unsolvable business crisis that was just squeezing the life out of the entire industry. This quote from Nick Willits, who's the CEO of a major industry group called the TM Forum, well, it just lays it all out there, doesn't it? He's not trying to sugarcoat it. And that word he uses, hurting, it's so important. This isn't the kind of hurt like a minor dip in quarterly profits or a stock price taking a temporary hit. No, this is a deep, systemic, chronic pain. It's the pain you feel from capital costs that are just constantly rising, making it more and more expensive to borrow the literal billions of dollars you need to build and upgrade networks. It's the pain of trying to modernize decades of old, creaky, unbelievably complex legacy technology, a kind of technical debt that has finally come due. But the real, bleeding wound, the core of the crisis, is the business model itself. Imagine being trapped in a cycle of making these absolutely colossal investments. We're talking billions upon billions for each new generation of network, without any clear, confident, or reliable path to actually getting a return on that money. That's the pain he's talking about. Okay, these two simple bars on the screen, they visualize the entire crisis in one perfect, brutal image. On the left, you've got traffic growth. And notice, it's not just a straight line going up, it's an exponential curve. Every single year, all of us, we demand more. More video streaming, more online gaming, more cloud storage, more everything. The demand for data is explosive. But then, look at the bar on the right. That represents what the network operators actually get paid for carrying all that traffic. It's a metric called average revenue per user, or ARPU, and it is dead flat. Just think about this with an analogy. Imagine you run a delivery company. 10 years ago, you delivered, say, 1 million packages, and you got paid $1 million for it. Fair enough. Now, fast forward to today, your customers, they're demanding you deliver 30 million packages. But here's the kicker. They're only willing to pay you, well, still about $1 million. What would happen to your business? Your costs would absolutely explode. You'd need more trucks. That's your capital expense, your CapEx. You need more fuel, more drivers, more warehouses. That's your operational expense, or OpEx. All your costs would just skyrocket. But your income? It stays flat. Your profit margins get crushed to nothing. That is the nightmare equation that telcos have been trapped inside for the better part of a decade.
And to put a real number on that investment pressure, just look at this, $122 billion. That is how much money the global telecom industry poured into building out 5G networks in a single year. A single year. This bet wasn't just about making our Netflix streams a little bit faster on our phones. The entire business case for 5G was built on a huge promise. It was the promise of unlocking this brave new world of high-value services for enterprises, things like fully automated smart factories, remote-controlled mining equipment, even telesurgery. But here's the hard truth. That promise, so far, has really struggled to materialize at scale. And that leaves that colossal, eye-watering $122 billion investment with a very, very foggy path to ever becoming profitable. The pressure is immense.
Now, the final piece of this crisis puzzle is a colossal structural inefficiency that's been hiding in plain sight for decades. Traditional networks are, by their very nature, designed for peak. The power grid analogy here is absolutely perfect. Think about it. Your local electric company, they have to build enough power plants to handle the demand on the single hottest afternoon of the summer, when every single air conditioner in the city is blasting on full. But what happens on a cool day in October, or at 3 in the morning? All of that incredibly expensive generating capacity, it just sits there, completely idle, burning money but producing nothing. Telco networks are exactly the same. They are built with massive amounts of expensive, specialized hardware to handle peak traffic, like when a football stadium lets out after a game. But the rest of the time, that hardware is massively underutilized. This over-provisioning is like pouring gasoline on the fire of the operator's financial dilemma. The only way out, the only possible solution, is to completely change the philosophy, to move to a new model, an on-demand, intelligent, and radically efficient network that can allocate resources dynamically, just like the cloud does.
So if you're an operator stuck in that trap, how on earth do you escape? Well, that brings us to Act 2, the Great Unbundling. The first truly revolutionary answer to this crisis came in the form of a brand new philosophy, a new architecture called Open RAN. And it promised something radical. The idea was to take a sledgehammer to the closed, proprietary black boxes of the past, to break the stranglehold that a few very large vendors had on the market, and in doing so, unleash a whole new era of competition, innovation, and lower costs. It was a message of hope.
To understand Open RAN, you have to understand the fundamental architectural shift it represents. On the left side here, you see the old world, the monolithic RAN. You can think of it like a fortress. You bought the whole thing, the hardware, the software, the whole black box, from one single vendor. It was simple in one way, one throat to choke, but it was also a straitjacket. You were locked in. Innovation moved at the vendor's pace, and costs were high. On the right, you see the new world, the disaggregated RAN. Think of it like a big box of Legos. The network is unbundled or deconstructed into standardized components with open, standardized interfaces connecting them. We use a great school campus analogy for this. The radio unit, or RU, is like the speakers and microphones in every classroom. The distributed unit, or DU, is like the homeroom teacher, handling all the real-time, in-the-moment tasks for that classroom. And the centralized unit, or CU, is like the dean's office, coordinating all the teachers and managing the whole school system. By standardizing the plugs between these different Lego bricks, operators could, for the very first time, pick and choose. They could buy the best RU from one company, the best DU from another, and the best CU software from a third. The promise was choice, competition, and a Cambrian explosion of innovation.
The promise of Open RAN was just incredible. The initial excitement across the industry was palpable. You could really feel it. It felt like a genuine revolution was at hand. But as we've seen with so many revolutions, that initial sky-high hype soon crashed headfirst into a much harsher reality. And this quote, it just captures that disillusionment so perfectly. The grand, sweeping vision of multi-vendor innovation was slowly, painfully chipped away, until, for many, it became just another line item, a dry checkbox on a purchase order that said ORAN ready. The industry had hit what consultants call the trough of disillusionment. So what on earth happened? Who or what extinguished that revolutionary fire?
It turns out that this great unbundling, it created a brand new, terrifying monster, the responsibility maze. Let's break this down. In the old single-vendor world, things were simple in one respect. If something broke, if your network performance was bad, you knew exactly who to call. The vendor was on the hook for end-to-end performance. They were responsible. But in the brave new multi-vendor world of Open RAN, who's responsible when a radio from vendor A doesn't seem to work properly with software from vendor B running on a server from vendor C? Suddenly, the responsibility shifts entirely from the vendors to the operator. The telco itself is forced to become the system integrator. They have to bear all the risk, all the cost, and all the mind-bending complexity of testing, validating, and troubleshooting dozens of disparate parts to make them all work together seamlessly.
This integration nightmare, this responsibility maze, became the single biggest barrier to realizing the grand promise of Open RAN. And that difficult reality brings us directly to Act 3, the cloud-native foundation. Okay, so if Open RAN created this incredible new world of choice, but also of overwhelming complexity, the industry desperately needed a new set of tools to tame that complexity. And the answer, it turned out, didn't come from the traditional telecom world at all. It came from the cloud. A whole new philosophy of automation, embodied by open-source projects like Google's Nefio, promised to bring order to the chaos.
The core of this new approach is a complete, fundamental, philosophical shift in how we think about automation. On the left side here, you see the old way, imperative automation. It's like a long, incredibly detailed recipe for a complicated cake. It says, do this, then do that, then do this third thing. It's extremely brittle. If step 1251 out of 2000 fails for some tiny reason, the whole process grinds to a halt and the cake is ruined. On the right, we have the new, declarative way, which was really pioneered by Kubernetes. It's like a GPS. You don't give your GPS a list of turn-by-turn directions. That would be crazy. You just declare your intent, your desired end state. Take me home. The system itself is smart enough to figure out the how. And this is the magic part. If it hits a roadblock, like a traffic jam or a closed road, it doesn't just give up. It recalculates. It finds another way. It is constantly, relentlessly working to reconcile reality with your declared intent. This is the very heart and soul of cloud-native automation.
So, how does this declarative dream work in actual practice? Well, a project like Nefio implements it through this beautiful, elegant 5-step automation assembly line. Let's walk through it. First, an operator defines their high-level intent, not code, but a business goal. I want a new 5G core network in our Paris data center. In step 2, the system automatically fetches a generic reusable blueprint for that kind of service. Think of it like a master architectural plan. Then, in step 3, a process called hydration takes that generic blueprint and customizes it with all the site-specific data. Things like the right IP addresses and security credentials for the Paris data center. Step 4 is absolutely crucial for control and safety. The final complete configuration is proposed to a Git repository. This allows a human engineer to review, validate, and approve the change. It creates an audit trail. Finally, in step 5, an agent running on the live network sees that approved change in Git and automatically reconciles reality, building out the network exactly as declared. It's a perfect closed-loop system that treats network configuration just like software code.
And this declarative philosophy, it extends all the way down to the deepest nuts and bolts of how Kubernetes works. For years, one of the trickiest problems in running telco workloads on Kubernetes was how to attach all the specialized network hardware. The community solution was, well, it was a hack. It involved stuffing big, messy chunks of JSON configuration into something called a pod annotation. It worked, sort of, but it was ugly, it was brittle, and it wasn't native to the system. The new approach, called Dynamic Resource Allocation, or DRA, is a world of difference. It is clean, it's elegant. Instead of a messy, unofficial annotation, a workload now makes a native first-class resource claim. The network finally becomes a claimable resource just like CPU or memory. This is the integrated, sustainable, truly cloud-native way forward.
Okay, so let's take a breath. We have now built our automated, declarative, cloud-native foundation. It's robust, it's scalable, and it can handle the complexity of a multi-vendor world. Now, we get to add the really cool stuff. This brings us to Act 4, the AI infusion. Once that powerful automated platform is in place, we can begin to infuse intelligence into the very fabric of the network itself, transforming it from a collection of dumb pipes into a living, thinking system. To really understand this AI infusion, a group called the AI RAN Alliance breaks it down into these 3 distinct but related pillars. The first one is AI for RAN. This is all about using AI and machine learning to make the radio network itself work better, improving signal quality, managing interference, and boosting efficiency. The second pillar is AI and RAN. This is a fascinating idea.
It's about turning all that expensive network hardware, which often sits idle, into a rentable, general-purpose AI computer for other tasks. And the third pillar, AI on-RAN, is the ultimate evolution, turning the entire distributed network into a massive edge computing platform for brand new, low-latency, AI-powered services. So the big question is this just a bunch of buzzwords, or does this stuff actually work? Well, let's look at the proof. This number right here, 280%, is frankly jaw-dropping. It represents the increase in data throughput at the single most frustrating place on any mobile network, the cell edge. You know the spot. It's when you're far from one cell tower and just getting close to another one. It's where your calls garble, your video buffers, and your connection drops. Traditional networks are just terrible here because of interference. But an AI-powered system can intelligently coordinate the two towers so they work together, creating a clean, clear path for your signal. A 280% increase isn't just a small improvement. It's completely transformative. It takes the absolute worst, most frustrating user experience and makes it amazing. This is AI for RAN in action, and it's real. And this AI intelligence isn't just about raw speed. It's also about making the network smarter and more responsive in everyday situations. A company called MediaTek has already commercialized some incredible AI features that use situational awareness to dramatically improve the user experience. Airport mode, for example, recognizes when you've just landed in a new country and intelligently speeds up that painfully slow network search. Crowded train mode optimizes your connection for video streaming when you're packed in with hundreds of other people on a fast-moving train. And my favorite, elevator mode, which predicts when the doors are about to open and prevents those annoying dropped calls. These are tangible, real-world examples that show how AI can make the network feel less like a utility and more like an intelligent assistant. Okay, our network is now open, it's automated, it's infused with intelligence. It really seems like our journey to build the network of the future is complete. But now, we have to enter Act 5, which is a kind of self-contained thriller, because lurking out there on the horizon is the ultimate threat. A ghost in the machine that could bring our entire digital world, everything we rely on, crashing down. I'm talking about a powerful quantum computer that would be capable of shattering every single form of encryption we use today.
This question really gets right to the core challenge of quantum security. The threat that we need to defend against, a cryptographically relevant quantum computer, doesn't fully exist yet, at least not publicly. So why the urgency? Well, the urgency comes from a deeply worrying attack strategy known as harvest now, decrypt later. What this means is that right now, today, adversaries are recording and stockpiling massive amounts of our encrypted data. Think government secrets, corporate intellectual property, financial transactions, private health records. They can't read any of it today, but they're playing the long game. They're warehousing it, waiting for the day that they finally have that quantum key. And on that day, decades of secrets could be unlocked all at once. It's a digital time bomb. This simple but frankly terrifying formula, known as the Moscow model, helps in the organization understand if they're already behind schedule. So X is the shelf life of your data. How long does it need to remain secret? Y is your migration time. How long will it take you to upgrade all of your systems to be quantum safe? And Z is the threat timeline. How long until a powerful quantum computer exists? So let's run a scenario. Let's say you're a government intelligence agency. Your data, X, needs to stay secret for, say, 50 years. You estimate that a full migration, Y, will take 15 years, so X plus Y is 65 years. But what if the experts are right, and Z, a powerful quantum computer, arrives in just 20 years? Well, 65 is much, much greater than 20. And what that means is that for secrets being created today, the vulnerability window is already wide open. This is precisely what is lighting a fire under the global security community.
So, how do we defend ourselves against this future threat? Well, our quantum defense arsenal essentially has two main families of weapons. On the left, we have post-quantum cryptography, or PQC. This is a new generation of encryption algorithms whose security is based on new mathematical problems that are believed to be hard even for a quantum computer to solve. The huge advantage of PQC is that it's essentially just software. It can be deployed as a firmware or software upgrade, making it relatively cheap and easy to roll out broadly. On the right, we have quantum key distribution, or QKD. Its security comes not from math, but from the fundamental laws of physics. In theory, it offers perfect, unhackable security. The catch is that it requires new, dedicated, and expensive hardware, like specialized fiber optic links. So the smart strategy here isn't PQC or QKD. The smart strategy is PQC and QKD, using each weapon where its specific strengths make the most sense in the network.
We've now reached our final act. We've navigated the business crisis, the technology shifts, the automation platforms, and even the existential security threats. But for this entire massive transformation to actually succeed in the real world, the industry must conquer what is by far the most difficult challenge of all. It's not about code, it's about culture. Act 6 is about zooming out from the technology to focus on the human and cultural revolution required to, metaphorically, rebuild the Tower of Babel.
This quote comes from a wonderful story that I think just perfectly captures the kind of cultural shift that's needed. A person is at a very trendy modern cafe. They have eggs on the menu, they have toast on the menu. All he wants is a simple fried egg on toast. But the waiter, after looking at his digital ordering tablet, comes back and says, "Sorry, that combination isn't an option on the tablet. I can't put the order in." Now think about that. That cafe had all the right ingredients, all the right components, but it was too rigid, too defined by its preset products to deliver what the customer actually wanted. For years, telcos have been exactly like that cafe, trying to sell complex, pre-packaged, predefined solutions. The future demands that they shift from being product rigid to being customer flexible. They have to learn how to make a simple fried egg on toast.
The house versus apartment analogy is the perfect way to explain the deep, internal human pain of this cultural shift. As Colin Bannon from BRC says here, this is a deeply uncomfortable experience. For decades, if you were a product manager at a telco, you owned your own house. You had your own budget, your own dedicated tech stack, your own team. You had total autonomy. You were the king of your castle. Now, the company is effectively demolishing all those individual houses to build one giant apartment building, a shared, common, efficient platform for everyone. The company gains massive efficiency and scale, but you lose that cherished autonomy. You have to negotiate with your neighbors in the other apartments. You have to use the shared plumbing. For many, this feeling of loss, this threat to their identity and power, is the single biggest internal barrier to making transformation happen.
So what is the ultimate vision? Where is this all heading? It's captured perfectly in this idea of the toolbox of components model. This represents a truly fundamental shift in identity, from selling finished products to selling raw capabilities. It means you stop trying to sell the fully assembled car and you start selling the engine, the wheels, the chassis, and the steering wheel as individual components. The best example of this in history is Amazon Web Services. AWS didn't set out to build Netflix, they just focused on selling the raw components of compute, storage, and networking through simple APIs. They provided the toolbox. And then an ecosystem of innovators, like Netflix, came along and used those tools to build an empire. This is the future for telcos, to stop trying to invent every service themselves and instead provide the network toolbox and empower a global ecosystem of developers to build the next generation of amazing things.
This brings us to what I think is the ultimate synthesis of this entire epic journey. For decades, the network was like a fixed-function Nokia phone. It was incredibly reliable and really, really good at one thing, making calls. But through this massive transformation that we've just walked through, the network is becoming something entirely different. It's becoming a powerful, programmable iPhone, a global distributed computer. And things like 5G connectivity, well, that's just the first killer app running on this new, incredible platform.
And so, after this long and complex journey, we end here. For more than a century, we have thought of our global networks as plumbing. Complicated plumbing, yes, but plumbing nonetheless. But we've just seen how that plumbing is being ripped out and replaced. It's being transformed from a system of dumb, static hardware into a programmable, AI-native computing platform that is distributed across the entire planet. This completely reframes the future. It's no longer just a technical challenge of connecting things. It's now a creative challenge. And so it leaves us with one final, provocative question. With this new, planetary-scale platform for creation now being built, what will we, as a civilization of innovators, creators, and dreamers, choose to build next?